All right, everything's set up. We're just on time, and I'm going to definitely use the time that we have here. So let's start right now. Welcome back, maybe. How many of you have been to my Spring Framework Roadmap Quickie, the slightly improvised one? All right, just in the other room. The original arrangement was actually the other way around. The Quickie was supposed to follow up on this one, but the schedule didn't work out any other way, so I had to do the Quickie first. And you know how those things go. Anyway, for this session here, it's about the Spring Component Model story. It literally is a storyline. So I'm going to basically tell you a story about the Spring Component Model from its very core principles up to the various endpoint models that we have in Spring these days. This is an entirely source code-based presentation. It's just slides. I'm not going to do live demos because we are going to have a design discussion. It's almost a design study. But we're going to look at plenty of source code. So no bullet points in this one. No animations either for those having been to the roadmap talk. So just very quickly, my own role. My name is Juergen Hoeller. I have been leading the Spring Framework project for many years now. I'm actually doing it for 12 plus years. It's going to be 13 in just a couple of months' time, 13 years. So I've been guiding the Spring Framework core project from its very early inception, literally from the setup of the SourceForge project up until today, where the Spring team resides at Pivotal and, well, actually does more things, brings out more things into open source glory than ever before. We're going to take a Spring Framework perspective here. I might make a mention or two of Spring Boot and other projects, but fundamentally it's about the core programming model, which to the day still lives in the Spring Framework core project, including many of the endpoint arrangements. So web endpoints, WebSocket endpoints, messaging endpoints, all of those things come out of the core Spring Framework project. I'm currently working on arranging Spring Framework 4.2 along with Boot 1.3, so Boot 1.3. 4.2 based is coming up any day now, but Spring Framework 4.2 itself has already been GA, generally available, since end of July. So it's already out for a couple of months, and we're working towards 4.2.3 right now. All right, about the 4.2-ness, maybe a quick note. This talk will highlight many features in the Spring Component Model. And the point of the talk is that it does not really matter where and when those features have been introduced. In many ways, the Spring Framework Component Model should be looked at as a coherent, comprehensive whole right now, not as a sequence of version numbers. So the Spring Framework 4.2 just means we're talking about the component model at the very current state of the art, as it is in Spring Framework 4.2. Obviously, there are some new 4.2 features in there, in particular for the ones with a lot of Spring usage experience already. There's a subjective selection of many features in here that are more personal favorites of mine, really. Some might even look a little bit esoteric, a little bit nuanced, but they make a lot of sense. They are underappreciated, not as well known as they should be from my perspective. That's why I kind of baked them into this presentation. So there is quite a bit of 4.2 stuff in there, and I will be dropping a note when we are talking about a brand new 4.2 feature. All right, let's start the story where it begins, with the core component model. So I assume most of you are familiar with the core model. Can we maybe do a quick inverse poll? Who hasn't had much experience with Spring before? Not much opportunity to work with Spring. Is there anyone in here who has not seen any Spring before at all? All right. I hope the presentations can be followed even with very little Spring exposure before, but of course it helps if some understanding of the core concepts is already present. All right. This kind of component class highlights the typical Spring annotation-based component style. It's annotated with a stereotype annotation, at service on top, at service indicating a role for this class. So from a source code perspective, we're looking at a piece of Java code, right? A regular Java class following standard object-oriented principles. It's implementing a service interface. It has a name, myBookAdmin service. It even says service in the name. But the annotations used on this class add a notion that otherwise isn't present. We formally declare this class to have the role of a service. We can reason about it. We can introspect this at runtime. Tooling understands that it has a service role. It can be used as an indicator even for generated component model graphs of your application. Right? The service annotation formally declares it as a service instead of just naming it service. The auto-wired annotation found on the constructor here indicates that this constructor is supposed to be auto-wired at runtime. Auto-wiring in Spring terminology means that its parameters are going to be resolved against components known to the Spring application context. So Spring is going to select, possibly create, a corresponding account repository and inject it for you. If there is no other metadata indicating otherwise, Spring is going to select this constructor and going to resolve it that way. That's what auto-wired means, an auto-wired constructor. The naming of the annotation describes the role of the constructor. There might be other constructors which are just meant for manual use, for programmatic use. They wouldn't be annotated with at auto-wired then. The update book method down here is a service method. Let's assume it's also present in the bookadmin service interface, but not necessarily. It's annotated with @transactional. @transactional is it's one of many annotations in Spring that allow you to tap into a typical middleware service, into a runtime processing arrangement. Usually backed by a transaction manager at runtime, Spring is going to intercept a method, start a transaction first, call the body of your method, and trigger a commit or a rollback when the method returns, when your method body returns. So much for the runtime semantics, pretty commonly known anyway. From a source code perspective, @transactional, well, describes the method, right? It tells you something about the method. This is a transactional method. We formally declare that this method has transactional requirements, transactional semantics. The reason why I'm highlighting the source code level so much is because we are staring at source code all day long as application developers. Source code is the essence of what we're doing in terms of what we work with, even if the outcome is a binary. Spring's annotations, in particular, really work well at the source code level. You can read them nicely. myBookAdmin service is a lazy service. The myBookAdmin service constructor is auto-wired. The update book method is transactional. It's about readability, about understanding the purpose of your source code. So those annotations may all have a runtime role, but they also have a descriptive role. They tell you something about your class that otherwise the Java code itself wouldn't be able to express, or not as easily anyway. All right, so much for the core purpose. Let's have a run through a couple of variants. Annotations in Spring can be composed. This is a pretty core feature, in particular in the Spring Framework 4 world. It's a very powerful mechanism. It allows you to build custom annotations, such as this one, a custom stereotype, here dubbed my service, but obviously you're free to choose your own name. I mean, by all means, please use a proper name. I'm using the my prefix consistently in this presentation, but by all means, please use a name that indicates something in your architecture, that has a meaning in your architecture. You could call it order service, account service, or even just based on some vertical or some horizontal slice, give it the proper name that indicates its role in your architecture. If you're building such a custom annotation, you can meta-annotate it, put annotations on your annotation type. So this public add interface is just a regular type in your own code base. Annotations are, after all, just regular Java types. The meta-annotations would typically come from Spring itself. So your my service here is meta-annotated with @service. It kind of inherits, shares the characteristics of a standard Spring service annotation. It changes the default scope to session. It indicates a default primary role, which is a hint resolved in case of type match ambiguities, where more than one type matches. It's always the primary one that wins, if there's no qualifier in particular. That can be a default characteristic, and it is here. And there's even a default transactional rule, applying to all public service methods of this class, instead of repeating the transactional annotation on each method. This combination of characteristics is now baked into your myService annotation. Every time you're using @myService in classes in your codebase, could be all across a really large codebase. Every time you're saying @myService, what you really mean is the combination of semantics above. From that perspective, it's a shortcutting model. So it allows you to combine characteristics into one sweet shortcut. But it's way more than that, right? A name freely chosen. It can be a stereotype that has a meaning in your architecture, and it also carries those combined characteristics. Composable annotations can have attributes as of Spring Framework 4. And the attributes would typically mirror an attribute from a standard Spring annotation. Generally speaking, composability of annotations works everywhere in Spring. In particular, in 4.1 and 4.2, we made sure that we allow you to compose annotations almost anywhere. You can compose your own @bin annotation, your own @autowired annotations, your own mapping annotations. Almost anywhere where you're currently using a Spring annotation, you could use a custom annotation instead that's meta-annotated with the Spring annotation that you're using there. And that works out of the box. Nothing to register, just do it. We auto-detect that you're using the meta-annotation model. So if you're using this, if you choose to use this, you may build custom scoping annotations, like my session scoped above, a name of your choice, of course. So again, the my in there in this presentation. And instead of just hard coding the session scope, which is some value in its own right, there's no free scope name anymore. You're hard coding the session, which means no typos. It's type safe from that perspective, right? Nothing can happen to the session type name here, scope name here. So my session scope has an attribute, proxy mode, which mirrors the same named attribute on the Spring @scope annotation. Through redeclaring it on your own annotation, you allow your users, the users of your annotation, to change the proxy mode, to influence the proxy mode. In Spring's scoping, proxying is basically off by default. You get the raw instance on request if you access a scoped component, and you can enforce proxying through target class or interface proxies on the proxy mode here. The proxy mode is set to no by default, so no change in the defaults, but you could choose a different default. Redeclaring an attribute means you allow your users to change it. You could also choose a different default. That defaulting thing may be even more obvious below. A custom transaction annotation called myTransactional. myTransactional redeclares the read-only attribute from the Spring @transactional annotation. So it's kind of a actually longer named version of the standard transactional annotation in Spring. You could choose a shorter name, right? Just call it myTX or just TX. You could choose a name as short as possible if you like to. This annotation here redeclares the read-only attribute. If you pay close attention here, the read-only attribute does not declare a default. There's no default for this annotation attribute here in Java language rules, right? No default statement. What does this mean? Everybody using your transaction annotation has to choose a value for the read-only attribute. So any use of @myTransactional has to explicitly say read-only equals true or read-only equals false, which just means you're forcing your users to set a concrete value, to reason about the read-only nature of this transaction, of this transactional scope, and to explicitly indicate read-onliness. Otherwise, it's too easy to forget, and everything's read-only false by default. So it's about guidance to some degree. It's about guiding a larger development team through the use of annotations, through the use of custom annotations, by allowing them to change some things but not others, through forcing them to set some attributes but not others. Because add_transactional has plenty of attributes. The only one we're redeclaring here is read-only. So no timeout change, no propagation behavior change, no isolation level change, just the read-only attribute. But that one has to be set. All right. A folder 2 feature. You can become more explicit here. You can choose to declare at alias for annotations. This annotation allows you to explicitly say that a specific attribute redeclares some other attribute, pointing to the type, to the annotation type, where the original attribute lives, and indicating the name of the attribute. This can be a way of self-descriptiveness, right? It can be a measure to take just to make it more obvious what actually happens here. If the previous example on the previous slide was a little too conventional for you, this might be a more explicit way of expressing the same relationship. It also allows you to change the name of the attribute. So my session scoped has a scoped proxy mode attribute called mode, not proxy mode. We're pointing to the proxy mode attribute, but our local attribute here is named mode. Of course, the naming convention would otherwise force you to call it proxy mode. The read-only attribute down here is actually the same, right? Here it's just explicitness. Explicit metadata saying, I want to override this attribute of that annotation here. Thank you, right? In a complex composition scenario where many meta-annotations live on the same custom annotation, it may also be a way to isolate the effect. So the moment that you're saying, I'm pointing to this specifically declared attribute over there, it's only really overriding that one. If there is a read-only attribute on any other meta-annotation, it does not matter. This one will not override it. So you're also isolating the effect of the redeclaration scenario. All right, so much for composable annotations. A change of topic to configuration classes. I suppose most of you have seen them in one way or the other. In the end, they are just regular Spring components with a special role in the container, because each of those configuration classes allows you to declare admin methods. They are fundamentally a container for admin methods in their own right. So a configuration class is an instance, a managed instance in Spring, can have its own auto-wired fields and so forth. It can have state of its own, but its purpose is to contain those factory methods that add additional bean definitions to the container. So in a typical modern-day Spring configuration scenario, you have a selection of configuration classes which combined make up the configuration of your system. No external metadata beyond those, possibly, except maybe for component scanning. So a typical modern-day Spring scenario has some configuration classes and some component scan instructions where you're just searching the class path for annotated components like add service, add controller, and so forth components, stereotyped Spring components, and auto-register them, right? So configuration classes and component scanning has a pretty immediate relationship and is often being combined. With component scanning, the container will create your components through regular constructor invocations. Default constructor or annotated auto-wired constructor. Whereas in a configuration class scenario, it's about factory methods. Every time the container needs to create a new instance of your bean, it's going to call back to the factory method that you're declaring here. The name of the factory method is the bean name. Right? Any other metadata sits at the method level. In this case, we are session scoping it, so we are going to get an invocation of this method for every new session where that component isn't present yet. Configuration classes can do many things. Admin methods can refer to other admin methods. The container understands that a call to another admin method is a symbolic call, so it's going to intercept it and it's going to use the right instance. It's going to, in case of a singleton, use the singleton instance, not create a new one. So there's a call out to another factory method, like indicated by the bookadmin data source call in there, is specifically handled in configuration classes. And configuration classes are a container for common configuration instructions, right? For common configuration arrangements. Like at enable transaction management, and at enable annotations are about activating certain container functionality out of the box in an explicit opt-in way, but in a very convenient way, very convenient opt-in way. So in Spring, you typically get what you declare, right? It's a what you define is what you get approach. We're not automatically registering a transaction manager or a thread pool or anything else for you. You need to opt in. If you want transaction management, say @enable transaction management once in your configuration arrangement, declare a transaction manager based on the conventions there, and the rest will be taken, the framework will take care of it, right? @profile above is an example for a condition. And both the @enable story, the @enable annotations, and the conditions can be found in boot, in Spring Boot, heavily. I mean, Spring Boot is basically conditions and @enable annotations on steroids. It really shows you how far this can be taken. So if you want to see the full power of the Spring Framework 4 configuration class model in action, just have a look at how boot works, how some of the boot configuration classes are designed. The condition model is extensible. Boot makes heavy use of that. It doesn't have to be as static as reacting to a profile setting. And @enable is a freely composable model. You can build your own @enable annotations. Spring Boot, in particular, ships quite a few of its own @enable annotations, but it's all built on the core Spring Framework configuration class story. All right, a couple of variants again. Configuration classes are regular Java classes. Regular Spring component classes and therefore regular Java classes. So they can use inheritance, because easy enough to do, right? From our perspective, it's more like the other way around. We let them be regular Java classes. What do we do if you use inheritance, right? Well, we try to derive natural semantics. We're going to go through the inheritance hierarchy and find @bin methods for you. So if you have a custom my application config class extending a base class, that base class happens to have @bin methods, then your my application config class is going to inherit all of those. You can selectively override some of those @bin methods, otherwise you just inherit the factory method from the base class, right? So it is Java inheritance at work, selective overriding if you choose to do so. You can of course also have abstract base classes, right? Leaving some factory methods without a body, undefined, abstract, allowing you to compose configuration fragments where the concrete subclass substitutes some of those points to arrive at an actual concrete configuration arrangement. So configuration classes are a pretty powerful tool. They are Java classes after all. In Spring Framework 4.2, we are applying the same reasoning to Java 8 default methods. What do we do if you choose to declare a configuration class that implements an interface? Look at the implements class, my book-admin config, and in the interface, you chose to declare some default methods, Java 8 default methods. Methods in an interface with a body. Obviously not accessing any state, it's an interface, but with a body. Well, we do the obvious now. We find them for you. We need to explicitly find them. We find them for you, we automatically register them for you, just like if they were present on a base class. So it's now another tool in the configuration class toolbox. You may choose to move some common @bin definitions into configuration interfaces with default methods. Your concrete class could then implement more than one of those interfaces, right? Implements my book-admin config and my system config. You could implement several interfaces to get a multiple inheritance scenario. Not arriving at any state clashes, just getting all those @bin methods according to the standard Java 8 default method rules and just collapsing them into one configuration class, which may selectively override some of those or not. Standard Java 8 language semantics applied to the Spring configuration class model. All right, a couple of other little nuances. Did you know that you can order configuration classes? It's new in 4.2. As a kind of special purpose thing to do, right? If you have several configuration classes and you find the configuration classes themselves through component scanning in the class path, you don't actually have a well-defined order. The class path iteration may almost have an arbitrary order. There's no well-defined order from class path resources. In particular, if you change the JVM or upgrade the JVM to a new, from like 7 to 8, you might get a different order. What if you actually rely on ordering in some specific arrangements? What if some configuration class absolutely needs to be executed, and it needs to be instantiated before that other configuration class? Because you're setting up some static state, you're initializing some whatever resource underneath that needs to happen first. You could use standard Spring means, you could, to some degree, even use injection relationships or depends on relationships, but you could also simply order your configuration classes through add order annotations. Spring has a common add order annotation, has had it for a long time, and it's almost universally used. Many components in Spring can be naturally add ordered, even configuration classes. That's the way to look at this. If you happen to express an order on configuration classes, we're going to take it into account and always initialize the one with the lower order first. In this particular case, it was even for name-based overriding, if you spotted that, right? Because there's a same named method. In this case, name-based overriding applies, and the class above has the more special version that means to override the other, so it always needs to come after the other, because last one wins with name-based overriding. But there may be other reasons why you're doing this. Right, slightly different topic, injection points in Spring. The design of injection points. An injection point is the simplest one that we've seen is the auto-wired constructor. Right, an auto-wired annotation on a constructor asking for a specific dependency to be injected. There could be a number of dependencies. You can have any numbers of constructor arguments after all. Each one of those is going to be resolved individually. The most important part is that the type really matters. So if it's not just a regular Java type, if it's a generic type structure, if you say, this my Pocket bin service here wants a my repository of account, what does this really mean? And how does the framework react to it? Right? In traditional Spring Framework 2 and 3, we've only really looked at the primary type. And in addition to the primary type, we resolved qualifiers, matched qualifiers for you. Some additional metadata that suggests which my repository you mean, if there's more than one, right? The problem only really manifests itself if there's more than one my repository implementation in your context. In your context, more than one my repository assignable bean definition. Doesn't matter whether there are other classes on the class path. Just matters what's registered with the Spring application context. All right. If there's more than one, it's a good idea to use generic types, generic type variables. Let's assume that my repository has a type variable that's substituted with account here. As of Spring Framework 4, we're taking the full generic type structure, any complexity, any level of nesting into account. We're going to find an assignable match based on the generic type assignability rules in the Java compiler. So we're going to look for matches for the primary type. We're going to find two my repositories first. Among those candidates, the my repository of account and the my repository of product, just suggested by these admin methods up there, probably living in a configuration class in a different corner of your application code base. But they need to come from somewhere. So let's assume they are admin methods. We find both of them. Then we take the generic type structure into account. And we find out that only one of them matches our declaration. There's only one my repository of account. In this case, it's even an exact match. It actually works with assignability rules. So even if the one above is a my repository impl of account, which happens to be assignable to my repository of account, that's OK. It just needs to be assignable. So we're going to do the right thing and choose the my account repository above for you without any extra metadata. No qualifiers involved. In Spring Framework 3, you would have had to add like an add qualifier account down here and an add qualifier account up there, or some other arrangement that hints at which one you want to pick. But now it's about the type declaration. If the type declaration is expressive enough and sufficient to resolve the dependency, then that's all you need to do. in a Spring Framework 4 world, we're on a mission to explore the type structures to the best possible degree and to avoid extra metadata wherever possible, if the type itself is expressive enough. This is one of the examples I have in this presentation. There's another one coming. All right. So generic type structures can, of course, also be used in combination with, for example, collections. What if your injection point down here declares that it wants a list of my repository of account? Well, simply enough. We're doing the obvious thing for you, hopefully obvious. You said you want all my repositories of account collected into a list. That's exactly what we're doing. We're going to look for all my repository bean matches, my repository of account bean matches. In this sketched scenario here, we find 2 of them. We're going to build a list and collect them into a list. If you happen to give us add order values, like we had before, right? Add order values next to the bean declaration point, we're going to pre-order them for you into a list where the my account repository Y is going to come before my account repository X. And we're going to inject that list into your constructor. Of course, that works with arbitrarily deep structures, and it's again an assignability rule. If the Java compiler would allow you to assign the target bean to an element of that list, then we consider it a match and are going to include it in that list. A nice little variant, again, a recent Spring Framework feature, is laziness of injection points. So in this case, again, a regular my repository of account, not a list. But this time we're saying, please give me a lazy reference to this my repository of account. What does lazy mean in this context? Lazy can be put at declaration points, right? It's actually also up there, right? The factory method has an add lazy. Add lazy at the bean method level has the same effect as add lazy at the stereotype level, at the component type level. It suggests that the container will, please, create it as late as possible. It tells the container to not create it up front, in particular if it's a singleton, that really matters, right? It's not created on startup, it's created the first time somebody's trying to obtain a reference to it. Well, trying to obtain a reference to it is exactly what this constructor does. And semantically, a regular injection point is asking for a fully initialized version of that dependency, of that bean. So if you have a regular my repository of account injection point, you basically semantically saying it needs to be fully initialized. I insist on it. With add lazy, you're expressing that it's okay if the target bean is not initialized yet. You just want an invocable reference. You don't want a fully initialized state over there yet. So it changes the semantics of the injection point. What this will result in is a lazy initializing proxy. It's a proxy implementation of your my repository. The first method invocation on that proxy is going to trigger the actual instantiation, the actual creation of the target bean. But chances are that you're not going to invoke it right away. You're going to store the reference in some field, and you're going to invoke methods on it later on. Semantically, add lazy is a good idea in that context, and in some scenarios, it may make an enormous difference. You could even break cycles between beans that way. A cycle between bean A and B, and another reference from bean B back to A, is only a problem if both ends insist on a fully initialized other. If one of them says, I'm okay with a reference, a lazy initializing reference, the cycle is not really a cycle anymore, at least not in terms of resolvability at runtime. It's then just a conceptual cycle. Please avoid cycles between components, but if you happen to have them, they might also come implicitly, through some role of your components, some listener role of your components. There are many reasons why you might end up in a cycle one way or the other. Right, so add lazy can do this for you, and it's a simple little innocent-looking annotation next to the parameter type of your constructor. That's all it takes. All right, variants of annotated components in Spring include components where you intentionally choose to not use any Spring inputs, not use any Spring annotations. So Spring traditionally supports standard JavaX .something annotations, some of them shown here, like managed bean as a simple stereotype coming out of GSR 250, @inject as a replacement of @autowired, maybe not quite as readable, more like an instruction in terms of its naming, but it has the same purpose essentially. And predestroy is an example for a lifecycle annotation, also coming out of GSR 250. So if you use them in your components, Spring is going to auto-detect their use, their presence, and it's automatically going to react to them. No need to configure anything extra, really. So it's your choice. Some components may use standard annotations, some may use Spring annotations. You may even mix and match JavaX annotations and Spring annotations in the same class. So we implement them as individual concerns. So you may use @inject with Spring stereotypes, or @autowired in this context here. No problem at all. Your choice. A nice little variant that works best in this context here is our support for optional, also a pretty recent Spring Framework feature. Optional is a Java 8 type, Java util optional. You're basically saying, look at the constructor here, you're saying, I want a my repository of account, but if it's not there, I'm okay with it. Java util optional is one way of sending that signal. Declare it as optional of my repository of account, then Spring's going to understand that you're saying that you want a my repository of account. We're going to look for it. If it's there, you're going to get an optional handle pre-populated with that reference. If it's not there, you're going to get an optional empty reference. And based on the Java util optional signature, you can then react to the presence or non-presence of that target bin in your constructor implementation. It's your choice, right? We're not forcing you to use optional. You declare optional, we react to it. Again, about the expressiveness of the signature, you said optional, we know what optional means. Actually, in a standard @autowired world, you have another option. You could say @autowired required equals false, in which case your injected references will be null if the target bean is not there, if no matching bean is there. So there is a way to do this with standard Spring annotations. You can also combine optional, of course, with @autowired, no problem with that. But @inject, javax.inject @inject, doesn't have a required flag. So optional is particularly useful in this context. All right, while we're with Java 8, why not talk about java.time quickly? This is a different scenario again. We're not in an injection point world at the moment, or anymore actually. We're now in a data binding scenario. So Spring getting some input data from some text representation, request parameters, or wherever else, and trying to bind it to a target class. In this particular scenario, Spring has a binding and formatting framework doing that work for you, a highly customizable one. That framework reacts to the types of your fields and your properties. We're seeing annotated fields here, where they come from the java.time package in Java 8, so those are Java 8 datetime types. One of them is declared as a local date, the other is a local datetime, and they come with @datetime format annotations, Spring @datetime format annotations. @notnull and @passed are actually supposed to come from the bean validation GSR here. They happily live next to this. So the @datetime format annotation on the local datetime field below specifies a pattern, right? It says, here's a parsing pattern and a rendering pattern. Please take this into account if a text representation is being bound to it, or if the field is being rendered out to a text representation. So all's good because that pattern is pretty individual, can be pretty individual anyway. The local date field above, the birth date field, doesn't have any special binding rules. You could assign an @datetime format in this case, saying @datetime format ISO date, standard date parsing rules. However, you don't have to do this because the type itself is actually expressive enough. You said local date. We infer the ISO date parsing from that type. So you can just omit the datetime format annotation. That's why it's commented out. You can just drop it. The type itself is expressive enough. You only need to add formatting and binding annotations if the type itself isn't expressive enough. So in the case of Java util date and Java util calendar, you almost always have to add them, simply because Java util date doesn't really say what it is. Is it a timestamp, a day plus time within that day? Completely unclear, really. Whereas the java.time types are pretty expressive in terms of what they are. Local date, local time, local datetime, zoned datetime, or instant. They say what they are. So they imply some parsing and rendering rules, much better than Java util date does. By the way, this also works with JODA-time. Actually, it's in Spring Framework 3.0 already. This is 4.0 plus. But you can still do it with JODA-time, right? If you happen to use the JODA-time types, they have the same names, even for those two here. We also auto-detect the use of those types and apply the same kind of rules. It's your choice in the end. We can do the same, as of 4.2, we can do the same even with the JSR 354 money and currency types. So if we encounter a binding scenario where you're asking us to bind a text representation to a monetary amount field from the javax.money package, we automatically detect that's what you're using is JSR 354 money and currency here, and we invoke the framework, the binding and rendering framework that comes with that JSR, unless you are adding a specific formatting annotation, in which case we, of course, are going to honor the instructions that you give us there. So the base price is going to be parsed with the standard setup in a JSR 354 money and currency provider, whereas the net price field below comes with a number format annotation. It's going to be parsed exactly according to that number format representation. So same idea as with the java.time or JODA-time types. So that's pretty new because JSR 354 is pretty new. It's only went GA in April. We shipped this in July here, so the timing just about worked out. Java 8 again, quickly, into more subtle usage scenarios. Add async types in Spring have a well-established meaning, of course. Call comes in, we're going to intercept it, wrap it into a callable, pass it onto a thread pool that you configured. You said add enable async somewhere if you're using Java-based configuration, and you specified a task executor somewhere, a thread pool processing those. So no automatical setup, but if you set it up once, you can use add async all over your code base, and that's the semantics that you get, async behavior on invocation. Since this is an asynchronous invocation, if you want to have a relationship connection back to your caller, you can return a future. So a regular future handle, a listenable future handle in Spring, or, as of Java 8, the one in the middle, a completable future. Completable future is a Java 8 addition. It's actually a concrete type, not an interface. It has plenty of methods that allow you to compose, to combine several futures into a combined future and that sort of thing, to react to the outcome in a nice follow-up way. As of current Spring Framework 4.2, we allow you to just declare completable future. We understand that that's what you're asking for, and we automatically take that into account, build a completable future for you, return it to the caller. The implementation of the async method needs to return its outcome, its value, its result as a completable future as well, syntactically, because that's what the return type is. And completable future, for that purpose, even has a nice completed future factory method. Whereas with a standard future, you need to use a wrapper like this async result above. So it's actually pretty nice if you're using completable future there. Automatically works if you're using Spring 4.2 on Java 8 and declare your return type like that. Add scheduled below also has a little Java 8 twist. It's a cron trigger, right? A callback for that method. Every time the trigger fires, the method is supposed to get invoked. But in this case, it's not one cron trigger, it's two, through two add scheduled annotations. Well, semantically not a problem, right? Just two triggers. However, according to the good old Java 5 annotation rules, you can only have one annotation of a specific type on the same method. or the same field, constructor, whatever, right? Same element. Semantically, you want 2 here. And as of Java 8, that's exactly what you can do. Just another @scheduled annotation. Because we declared @scheduled as repeatable, a new concept in Java 8, repeatable annotations. Annotations can opt in to being repeatable, so you need to specifically declare them to be repeatable. That's what we did for selected Spring annotations in the Spring Framework 4 generation. You can just use it like this. On Java 6 or 7, or with annotations not declared as repeatable, you would have to have a wrapper annotation, like an @schedules with nested @scheduled in an array. Pretty ugly. This is much nicer and much more natural. And even Java 6, 7 compatible. Obviously, you can't use them in a repeatable form there, but the same Spring Framework 4.2 version of @scheduled works in its regular form on Java 6 and 7 still. But on Java 8, the repeatable nature is being understood. All right, so for the remaining quarter of the presentation, let's move on to the endpoints. The endpoint model in Spring is pretty well established. Probably the most well-known are the web endpoints, HTTP endpoints. I suppose most of you have seen this one way or the other, so we're not going to dive deep into this particular example, but just a couple of things to note here from a design perspective. It's a regular Java class, has a stereotype on top. Here it says address controller, which is a Spring stereotype, meta-annotated with that component. Spring understands that. It even gives a general cross-origin allowance here, but let's ignore that for the moment, or for the purposes of this presentation. And it has a couple of mapping annotations. Methods, so-called handler methods, with a mapping annotation that indicates when to call that handler method, or where to bind that handler method to, depending on how you want to see it. Request mappings in Spring MVC are just HTTP mappings, binding to an HTTP path, potentially associating themselves with, restricting themselves against a specific HTTP method. Would be a good idea actually to do that for the second mapping down here as well. If you want that to be a post, why not say method post and restrict it that way? And nested parameter annotations. So have a close look at this findBook method. It says findBook wants a path variable long ID. This is a parameter in Spring MVC, and in general Spring endpoint models, you have the kind of analogous use of parameter annotations. Per request values are typically injected as parameters because a controller is typically a singleton. So its shared state applies to all requests, can have references to other components and so forth. But the per invocation state is typically request specific. In this case, we want to extract the value from the path where we have this ID binding variable, this path variable in there. Through the add_path variable annotation, we are instructing the framework to do the right thing, right? This is a long. I want you to get it out of this path variable with the same name, extract it and convert it for me, please. You could say at request param, at request header, at cookie value. There are different string or simple types to get out of a request. The parameter level annotation indicates which one it is. And it also adds to the readability. If you look at this piece of source code, you understand what it does through just looking at it, right? The findBook signature is self-explaining. The add_path variable annotation is actually a significant hint in the source code, not just a runtime hint. This long ID parameter is a path variable, right? It's a path variable of type long and name ID. Reads pretty nicely. Let's have a look at some endpoint variants that you might not be as familiar with. If you're using the STOMP messaging protocol, typically, but not necessarily, on a WebSocket channel, the corresponding endpoint model in Spring Core, this is actually Spring Framework 4 core functionality. Oh, oops, what is that? I'm sorry. For some reason, OpenOffice decided to just close itself. I'm not exactly. Oh no. I'm not sure what that is, but Windows background updates. Shit. Well, unfortunately, it's probably going to install, I don't know, 15 updates now, so I'm not exactly sure how we get out of this here. Does anybody have a laptop? No, I'm serious. This is actually a little bit of a pain. I tried to prevent it by, yes, of course, that's what it does, right? Okay. Well, I'm going to complete the story in some other ways and give you some, we were almost done anyway, to give you some insight into the endpoint design. So what you've seen were, remember, were message annotations, message mapping annotations. The consistency in Spring's endpoint model is actually about the style that you're using the mapping for, right? It's called callable handler methods. Each handler method has a mapping. If the mapping is to an HTTP path, that's what you've seen. If the mapping is to a message path, that's to a message binding, a message ID, an incoming message queue or topic, that's exactly what your message mapping annotation is going to express. In terms of extracting values from this per invocation state, you can typically extract the message payload. Our design guideline is simply to take the Spring MVC endpoint model and to make sure that the consistency, the readability that you're used to when you're looking at Spring MVC endpoints translates very naturally, very well to the annotated endpoint models. You can use this with STOMP endpoints. You can use this with GMS listener endpoints. You can use this with event listener endpoints. And you're going to find yourselves in familiar territory. That's the whole point of the endpoint design arrangement. The extension of it can be found, for example, in Spring integration. Even Spring integration has an endpoint model, a message endpoint model, that's very consistent. Even the Spring AMQP project with rabbit listener annotations has an endpoint model that is consistent with this design philosophy. Well, in terms of what's a recent feature here, GMS listener is actually a 4.1 feature and event listener is a 4.2 feature. So some of this stuff is pretty recent. Our mission at the moment is to complete the picture, to complete the programming model. This means that we are trying to identify gaps. Some things you can express in one version of the endpoint model, but not in the other. Some things you can do with GMS endpoints, but not with AMQP endpoints, or the other way around. And we're trying to make that as consistent as possible. This is actually something that we're working towards in 4.3. So in 4.3, if you are aware of some subtle incompatibilities between the endpoint models, design inconsistencies rather, that are not justifiable through the use of, well, the particular technology, meaning there's no good reason for it, right? I mean, some things are different between GMS, AMQP, and STOMP. They are different messaging protocols. They have different destination binding rules. Some things have to be different. Those annotations are specific annotations, particularly for the reason that they aim to take their target technology, take the full power of the target technology, and kind of bind to it in a natural form, right? So if you're binding to an HTTP endpoint, you know that you're binding to an HTTP request. If you're binding to a STOMP message, you know that you're binding to a STOMP message or a STOMP subscribe instruction. If you're binding to GMS, you know that that's what you're doing. You know that you need to be specific about the queue or topic, that you can use message selectors. Our endpoint design, our endpoint annotations lets you do those things. Work as closely with the technology as you like to. At the same time, having a design consistency, you can see where we're going with this, right? In Spring Framework 4.3, we have about 150 issues collected already in Jira. So you can have a look at kind of the gaps that we are already aware of, the little fine-tuning that we already intend to do there. If there's anything we're missing, or if you have any particular favorites, let us know. Comment on Jira, vote on Jira. We're taking that into account because we do aim for a release candidate in, well, at least in early April. GA target kind of late May, end of May next year. It's not that much time really, and we are working with an existing Spring Framework 4 arrangement, so we are not going to do anything radical. We're just going to fine-tune the model as much as it's needed in practice, right? And Spring Framework 5 has an opportunity to be a little bit more aggressive in some corners. All right, so that's really what we're working towards as a kind of follow-up to the design discussion. I hope that this little design story, even if it ended a little abruptly, kind of make sense in your ears. I hope that there's been something in there for every one of you. I'm pretty sure that hardly any one of you will have known all of those variants. Some of them are really pretty recent and not that commonly known. I'm happy to take any questions, since it's an opportunity, right? If I can't show you the remaining 3 slides, I'm going to let you ask a question or two in this forum here. Are there any questions about the presentation, about the Spring roadmap, anything that you have on mind at the moment? Any takers? Otherwise, let me invite you to the Spring BOF tonight, 7 p.m. if I'm not mistaken. There's a dedicated 1-hour Spring BOF session that allows you to have a discussion, raise questions, or participate and just listen to the discussions that we're having there. It's largely going to be about the coming roadmap, about Footer 3, 5.0 plans, but we're also willing to discuss any kind of Spring issues, really. So if there's anything you would like to raise with us, where it makes sense to have a discussion in the group about it, rather than an individual discussion, please come to the BOF and raise it. If you want to approach us individually, we're around, not just myself, but also a couple of colleagues of mine, Stefan Nicol, Brian Klosel, and Oliver Kircher. So if you find us around at the Pivotal booth or anywhere out there, please just approach us. We're happy to talk about anything Spring or anything Java, really. Well, one more opportunity to raise a question that we're covering here. Otherwise, one quick forward-looking note from my side. Our Spring Framework 5 mission for next year is closely aligned with JDK 9. If you have an interest in JDK 9, the module system as presented in today's keynote, then please, if you're a Spring user, right, or have a Spring interest, let us know what you expect to work for you here. Spring Framework 5 is going to be JDK 9 based out of the box. So it doesn't really have that much impact onto the component model itself. However, it does have an impact, obviously, on the Spring modules. We'd like to ship them with JDK 9 module metadata. Even more importantly, we would like to allow you to declare your components within a JDK 9 module arrangement and to let Spring naturally understand it and handle it. It doesn't really mean that much in terms of the framework itself. It's more about allowing you to refer to the framework artifacts through JDK 9 module names and module metadata. There's more in JDK 9, though. There's a new HTTP client planned. We intend to allow you to use this new JDK 9 HTTP client everywhere in Spring where an HTTP client is used underneath the covers, for example, in REST template. So if you have any interest in that combination of technologies, by all means, let us know. It's a little bit early still. We don't have a Spring Framework 5 branch yet, just a prototype project and R&D project for our reactive efforts, different feature theme in Spring Framework 5. We're going to create the Spring Framework 5 branch very soon now. So we're going to build it on JDK 9 snapshots from day one, and we'd like to include quite a bit of the JDK 9 feature coverage out of the box. So if you're willing to give that a try, the JDK 9 team wants you to give the JDK 9 snapshots a try. We want you to give the Spring Framework 5 snapshots a try on JDK 9 once they're out. So it's a particular invitation if you have some spare time where you spend the time on preparing for the future. That combination of technologies would be a great candidate. All right. Well, then, thanks for your attention. Thanks also for your extra attention after the disruption. Enjoy the conference and see you at the Spring BOF if you're up for it. Thanks.